we're spending 2 days on 6-2. So I'm not going to teach it all today. I could if you want. Oh, we're not doing shells. I should get that out of there. Shells have been taken off the exam, which is really nice. Now, generally speaking, they give you the diagram, but we're going to graph this anyway. Sometimes they don't. I like shells. I wish we were teaching them, but since we don't have to, I'm not going to. Well, it really helps figure out which is dx and dy. It really helps you figure those things out. Okay. Oh, I didn't bring my model. Oh, well. I want to consider this curve, which is bounded by, well, actually, let's not do the cross-section today. Let's do this Monday. I want to take this curve and bound it by the x-axis line, x equals 3. Now, here's what I always say. Read the problem twice. Do the problem once. Okay, can you graph that? Hey, guys. We can't miss a day. So if we don't have school Monday, if that happens, you have to think snow hard. I expect you to continue working on 6-2. We'll go to 6-3 on Tuesday no matter what. Last year's videos are always up. They're all up. All the videos are up. Am I missing something? But last year's videos are up as well. So even if you don't have a video for the cross sections, you can go and do that. But we can't afford a day. This is giving you your test on Tuesday, Wednesday of spring break week. Then we're done. I'd like to put it in fourth quarter, but it doesn't matter. I want to graph this. So the most convenient points are the intercepts. So if y equals 0, I get this. And we should know what this graph looks like. What does it look like? Negative x squared. It's an upside-down parabola, right? And I would like to find the x-intercept. So if I factor out x, I'm left with negative x plus 4. So x is equal to 0, or x equals 4. So I know what it is. So I'm going to draw that. I'm going to bound it by this curve. And I might make mistakes in how I do it. And then there's 4. I might have made that a little big, but whatever. And it's going to be also bounded by the line x equals 3. So I'm going to change colors and put x equals 3 in here. Actually, I'm going to do this. Okay, so we want this region. And even in AB calculus, say some people were getting the wrong region. So read the problem carefully. It's bounded by this curve, x equals 3, and the x-axis. So it's this region right here. And this is where your artistic skills come into play. And we're going to rotate that around the x-axis. Okay? So I'm going to cheat a little bit. I'm going to take this. Yes, I can. There it is. That's close enough. Okay. Now, some of you don't like to draw the pictures. I think drawing the pictures is the fun part. You're going to slice it this way. If I try to slice it this way, I'm not going to get a geometric figure I know what to do with. So I'm going to try to slice it this way. This is pure geometry. Why? I love these. Drawing them? I will put up a smart board also that I've gotten. Somebody sent one to me that has a lot of these pictures on it. I personally like to draw mine. Okay, so if I were to pull this little disc out of here, it looks like a quarter, right? When you slice it this way, you can see a circle there. So now the question is we're going to figure out the volume there, and the volume is equal to the area of the base times the thickness. What's the shape of the base? It's a circle. So that's going to be Pi r squared. You know why I like this? Because there's absolutely no memorizing. Because we all know this one. Okay, Marissa? And what is it? Is this going to be delta x or delta y? Which axis does it hit? X. This distance here is delta x. Now, on the exam, if you don't put in the differential, they won't mark it wrong. However, I'm trying to think if I graded this one. Don't remember. It was so long ago. But the problem is, if you don't put the differential in, oh, I did. I graded the one with the 2011, number 3. I did grade that one. You don't put the differential in, then you can get confused as to what r is. But if I put this in, now everything is determined. Everything is determined by this. So we want all x variables. So if you don't see where I'm getting something, please stop me, let me know. Okay, guys? Zach, is that okay? Nick, is that okay? Okay, I want x's in my equation. So I got to find my radius. Let's go and put, let's do a different color. Let's do purple. Here's the radius. This is what I mean by geometry. That's the radius of your disk. You have an ordered pair here, x, y. Which one would represent the radius, the x or the y? The y. So r is equal to y. Okay, so I'm going to set this up. So the volume equals pi y squared, and that's going to be delta x. I will integrate that, and I'll pull the pi out in front. And yesterday, guess what you guys forgot? You forgot to bring the pi. So don't forget pi. And then it's y squared, and it's dx. That tells me, this tells me that I have to have y in terms of x. Can't have any y's in my problem. We don't know anything about multivariable calculus yet. You can't mix your variables. And in AB, I call mixed vegetables. No mixed vegetables. It's got to be all y's, x's over here. So what is y? Is that function there, minus x squared plus 4x? And most of these are going to be calculator problems. Not always. Oh, I don't like that color. I like the color, but I don't want to do that. So it's minus 4x squared plus 4x, right? Is that right? No. Minus x squared plus 4x dx. And again, it tells me what variable. I'm going to look at my diagram, and what am I going to do this I forgot to do? Square it. U substitution will not work. You have to expand that. There's no other way. And so then you look up here and see where the x's are going from. My smallest disk is here, so my smallest x value is going to be what? 0. And then I'm going to put some disks in here. And what's my last x value? X equals 3. We don't get to 4. That's it. Do you know how to use the calculator to do that? On your calculator, I think we should go through it. You're going to do pi FNINT. Don't forget pi if you want a full decimal. And it's going to be, I'm going to put that in y1, and I want y1 squared, comma, x, comma, 0, comma, 3. That's what I want. What do you guys have to see on the exam? What you see on the exam is what I have right here. You may write the FNINT thing. That's fine. Nobody's going to get it. You're not going to give me any points for it. And in my last class, someone just wanted to put the answer down. I said, no, you have to give me the integral. I want to see what you're doing. You get a point for this part, which is called the integrand, and probably the limits with the pi. Or maybe the pi might go with that. I'm not sure. I have to look at the scoring rubric. So it's 3 points for each of these problems. So we're going to bring up the calculator. And if anybody wants to try my Inspire calculator, you may on my iPad. It's really quite interesting. What I also like to do is figure out how to do the 3D. Because the Inspire does have 3D, but I don't quite know how to do it. So I'm going to go y equals, I'm going to clear all that stuff out. If I can remember this now. Minus x squared. I like to put it in y1 because it's just easier. Plus 4x. And I'm sorry, I don't have any calculators. Nick, you should practice with this. Do you? What's the answer? We'll find out. So, should we do pi first? Second, pi, and then math. 9, F-N-I-N-T, and I want y1, so it's bars, the y variable. Now, if you have the new operating system, there's a shortcut for that. y1 squared, comma, x, comma, 0, comma, 3. Or you could leave your answer in terms of pi. Just don't forget the pi. So Nick did it right. Well, I assume he did it right because we have the same answer. Because that's what you do in engineering, because there are no answers. So you work on something, and you hope that somebody else comes up with the same answers. They hopefully check and double check and triple check. Okay, is that okay? John, is that okay? Okay, let's try the next one. Do you not even know how to graph that? What do you mean I can flip it around? So y equals 2 over x. Now I recognize it. And the line y equals 1, and the line x equals 0, and we're going to revolve around the y-axis. So I always draw it. I don't know how you can do this without drawing it. Oh, I've got an n bounded by y equals 4. That might be missing in your handout. Okay, Ori, you should be doing the problems with me. And I'm going to graph y equals 2 over x, which looks like this. And it's bounded by the line y equals 1. Y equals 1 is here. And y equals 4 is up here. Is it easy to misread those? And the line x equals 0. Well, that's this line right there. Okay, I need to change some colors here because I can't see it very well. Unfortunately, you don't get color. So I want the region enclosed by in this area right here. What's this going to look like? Do you know what it's going to look like? A volcano? I was thinking of a lampshade too. There you go. That's a little spread out. There we go. And you're going to slice it now horizontally. So you're right. It looks like a volcano. Want to slice it so that I get circles for my cross section. Okay, volcano. We could do that. That could be your project to make me some nice models. It's not an easy task. Well, we'll be doing something. I really think I should teach you guys vectors because vectors, well, here's the deal. And the students always come back every year and say you should teach vectors because but it's part of the curriculum that AP doesn't put in theirs. So they expect you to know vectors when you go there. So then you have to learn it. I mean, I could. Okay, now when you draw your radius, you start at your axis here, so you rotate around and draw it to the function. So what is the radius equal to? It's either x or it's y in this case. It's x. So the volume is equal to pi radius squared. What's the differential? Delta y. These guys are always opposite. When you do shells, which we're not doing, they're always the same. But I'm not going to teach you shells because then you'll want to use them and it might not apply. So it's pi x squared dy, and I'm going to integrate on the y's from y equals 1 to y equals 4. It might not be on yours. It might only be on mine, that y equals 4. So volume is equal to pi, and we're going to go 1 to 4. What's x equal to? Oh, that's why they gave us x this way. So it's 2 over y quantity squared. dy. It's done. Are we okay with that? We don't need to do the calculator, do we? Maybe somebody did. You could simplify it, or you could just put this. I would put this into y1 and then do y1 squared, just like I did. Yes, you'll enter it. What you'll do for entering it is you will enter FNINT, and you're going to do y1, y1 squared, comma x, comma 1, comma 4. You're going to enter it as x. You could do alpha, but then you have to actually type that in there because we don't have anything for y's. So in y1, we're going to put 2 over x. Well, these are easier problems. Could be. We could do it by hand. Did you remember the pi? How did I know? Because you gave me a nice, easy number. Is anybody? How many decimal places should I have? Okay. When in doubt, put them all down. Okay, guys? And those of you with the Inspire calculators, you're going to have to change your settings. If anybody has that, to float, just have it float, not or float 9. I can't ever get mine to work right, but okay, this one's a little trickier. Well, that's what somebody told me. Now, sometimes when I rotate them, I get holes in the middle. Yeah, they're washers. Right. Okay, we ready? Now, you think if you're rotating around the x-axis or the y-axis, you will get the same volume, but you don't. I don't have enough space. I'm going to move that way down. Okay, so let's graph that. And it's the same problem. It's rotated differently. Ooh. Okay, y equals x squared. I know what that looks like. Do you guys know what that looks like? But what about the other one? Y squared equals 8x. What does that one look like? It's a parabola on its side now. And you're right, it does come down here as well, but it doesn't intersect with this other curve, so it's in the first quadrant. I want to say it's always in the first quadrant, but that is not true. Now, we are going to rotate that around this region here, around the x-axis. I didn't do that very well. So it's kind of like a bowl. Which way are you going to slice it? Which way will give me circles? Vertically. Okay, so now we have, I'm going to color that in too. So it's this region here that you imagine that rotating around, and there's a hole in the middle. Okay? And so when I take a slice out of that, it's going to look like this. It's going to look like a washer. And I don't have any washers here. That's what it's going to look like. But it's going to hit this way, so it's going to come out at you. Can you see it? That looks pretty good. Oh, let me put the inside. Put the inside, the hole in here. There. Well, that's just a hole. Okay, so is it dx or dy? This distance right here. Okay, delta x, that's right. Okay, so the volume is going to equal, now I want the volume of the outer one. It's the area of the base times the height. So I'm going to take the volume of the big cylinder, so to speak, which is pi capital R squared times delta x. And then I'm going to subtract out the inside one. I'm going to subtract that cylinder out. Call that little radius. So that's what you're doing. You're taking the big one minus the little one. Okay, Ori? So what can I factor out of this? I? No, I can't. I can take out delta x2 and put it over here. And then I'm left with capital R squared minus little r squared. Is that the same as r minus little r quantity squared? Are those the same things? No. Okay, Sam? John, you guys get this? Because this is the common error on the exam. Students will do this. And you know what? It's all wrong then. So you can't do that. So now I have to figure out the radii. Now, what's the big radius? The big radius goes up to the top curve. You see that? So capital R is equal to this y value, y1. Little r is the little inside one. So little r is equal to, I'll call that y2. Okay, Trevor? So it's pi, and it's big, it's y1 squared. I'll figure out which one is which. Minus y2 squared, and it's delta x, and I'm going to integrate on the which variable? X's or y's? X's. Okay, so I have some work to do. But luckily, when I do the work here, it's not going to be so bad. So, which is the big radius? Is it the y squared one or the y one? It's y squared. Now, another mistake is not squaring that. I want y1 squared, but it's already squared for me, isn't it? What is y here? Y is equal to the square root of 8x. If I square that, what do I get? 8x. So this is 8x, not going to be 8x squared, minus that other y coordinate, which is equal to x squared, so you have to square x squared. Now, what's the last thing we have to do? Find where they intersect, right? So I probably could do it right here. I have y equals x squared. I have y squared is equal to 8x. I want x's. You know what would be easiest to do is be to square this one, and I get y squared equals to x to the fourth. Since these are the same, what's got to be true about these? They're the same. So x to the fourth equals 8x. Can't solve it. To solve any equation must be equal to 0. And if I factor out an x, what am I left with? X cubed minus b. Can you do that by inspection? Obviously, it's 0. What is this ordered pair? It's x cubed minus 8 equals 0. So x cubed equals 8. What number do you cube to get 8? 2. Oops, I already had the parentheses there. Okay. Can you find y anyway? You're right, 0 to 2, but You know what? I'm going to rotate this the other way, so I'm going to need it. So 0 to 2. What would the y coordinate be? I can use either one of these. I can either use y equals x squared or y squared equals 8x. So 2 squared is 4. Okay, do you guys want to try the next one? I'm going to rotate around the y-axis. Yes. It's colorful. Silly me, I should have made the picture twice. Copied it. Oh, nice picture. Take the same thing and rotate around the y-axis. Are you ready for me to draw it yet? Mm-hmm. Yes. Almost looks like rabbit ears. Should I color it? Oh, let's do blue. Well, I don't know what the answer is. You just have to integrate it. Now, some of these are without a calculator. Lately, they've been doing that, but last year they did not do it. And if you're doing arc length, if they asked you for the length of this arc, we could do that. But I haven't shown you how to do it yet. So it's okay. So let's draw our slices. I'm going to slice this like this. That work? Oh, you can kind of see it. Actually, this is going to be solid here. I forgot about that. But you can see that. So if I pull it out, it's going to look like this. Okay, so I got to get the radii in there because it's pi, big radius squared minus little radius squared, always, always. And what's the differential, delta x or delta y? Delta y. Thank you. Now, when you do the radius, always draw it to the function, not to its rotated image, because that'll mess you up. So this is the little radius. Which coordinate am I looking at? That's x1. Doesn't matter which one you call it. And then this is the big radius to the bigger function. So r, capital R, excuse me, equals x2. Okay, so my volume is going to be pi. R, big R is x2, so it's x2 squared minus x1 squared, and it's going to be dy. And that tells me dy that I'm looking for the y values. So I've got to solve for x in terms of y. And we had y squared equals 8x, and we had y equals x squared. Those are ones I can do. Pardon? Yeah, you could. I just usually do it because you were going to calculate it with two integrals. What are the y's going to go between? Because we already did that. Smallest one's down here. So it starts at 0 but goes to, remember the other y coordinate? We found it. 4. Okay, one more step. We'll put in our x values, and I just have to get them right. Not always easy to get them in the right order. If they have you integrate, you'll know it's in the wrong order if you get a negative number. And just put a minus sign out in front. Do not erase. Okay, so it's the big radius. So it's this one. Which curve is this one? That's y equals x squared. So if I solve for x, what's x equal to? Square root of y. Oh, I didn't have to do that. But anyway, it's the square root of y, and we're going to square it. Minus. And the little one, where is that? How do you solve for x here? X equals, I have to look at my picture carefully. This is y equals x squared. This one is sometimes they tell you y squared equals 8x. So I want the one that's further away from the axis, the larger number. So if I solve this for x, it's y squared over 8. And what do I have to do with it? Squared. And it's dy. So if I take my time like I did right now, I'm probably going to get it right. Let's just do simple. Now, if they said set up and do not integrate, I'd leave it just as it is. But this is y. This is y to the fourth over what? 64, because that's where the mistakes are usually made. That's right. On your calculator, even if you can do it by hand, I think, because this is very doable by hand, but I still think you're safer with your calculator. V is equal to pi. Don't forget the pi. And, sorry, I want that. FNINT. And we're going to put this one into y1. We'll put that into y2. And I'm just changing the variables. So it's y1. It depends how you do it. Squared minus y2. I would do it this way. I would put y1 is equal to, whatever it is, x squared. Because that's squared, square root of y. And y2 is equal to y squared over 8. X squared over 8. Oh, I'm sorry. Try that again. Y1 is equal to the square root of x. Y2 is equal to x squared over 8. You have to be in x's. Unless you type it in, otherwise you're in trouble. X, comma, 0, comma, 4. They're dummy variables, so it doesn't matter. If you want to do alpha z, you can, but if I put everything in my functions, then I can't. And don't forget pi. So, shall we, that was a tricky one. You guys want to try that one? Not a square cross-section. Those are the square cross-sections. We'll do those on Monday. But not this one. Or you want to do this? Huh? We could. You could try it. That's a great idea, actually. Okay, there are some questions on the homework. Homework, 6.1. All right, you had 2 problems for area. Are those okay? Okay. I'll do my best. I'm going to have to graph this because I don't know anything. Okay, so I have no idea what that looks like. I could figure it out, but this would probably be a graphing calculator problem. So we're going to go ahead and graph it. You're going to have to change your mode. We'll go to parametrics. Y equals and it's t cubed minus 2t second square root of t. And I'm going to look at my table. That's good. Just to get a feel for my values. So the y values aren't very big. I can't go negative, can I? Okay, so I might want to go up to 0 to 3 on the y's. Might. I don't like to do that. There we go. Now I got to go back and get my calculator. So my t values, let's go 0 to 4, because that only goes up to 56. 0, 4. My x values go up to 60. 0, 60. That's that cubic that's doing that to me. And then the y values will go up to about 3. 0. That's it. That's my curve. Okay. Is there oh, you're right. There's a -1. Sorry, I didn't even look at that. Let's make it -2. And that's okay. Let's try that. Oh, I've got a little thingy over there, don't I? So window. So I'm going to change the window. Oh, is this one we have to slice the other way? Make that 20. That's a better picture. Am I reading something right? Okay. Actually, I want just that little piece there because it's bounded by the curve, which looks kind of like this, and the y-axis. Which way do you want to slice that one? You want to slice it horizontally, don't you? Okay. Do I know where this is? Yes. Okay, so I don't know what to do. So I am going to write down what I would do normally. The area is equal to the height times the base, and the base is what? That's delta y. Yeah. And the height is this x value, which is 0, and then this x value. Call it x1. Why do I have to subtract it like that? Because if I do x1 minus 0, I'm going to get a negative answer. So the area is going to be equal to negative the integral of x1 dy. Now, what's x? X was t cubed minus 2t. T cubed minus 2t. Did I copy that right? And then what's dy? What's dy? 1/2 t to the negative 1/2. So it's this. Oh, yeah. I forgot my dt. Oh, how could I do that? That's bad. There. You have to have the dt in there. And there it is. How would you integrate that by hand? Oh, what are the limits? What's our t value from here? We start at t equal to 0, and where do we stop? Then we get this. T is equal to 2, x equals 4. I'm going to have to figure out where that is, aren't I? Got to get my calculator out. Oh, where is that? I don't know. But we'll trace and find it. Hang on. I want t. So we're going to trace. T is 0. Not infinity. We're going to. T is what? 1.35. Nope. That's better. 1.45. Is it 1.5? Did I not go far enough on my graph? Or did you just solve it algebraically? What's got to be true about x and y there? No, that's for this point. Oh, did I copy it wrong? How much for these contacts? I'm trying them out. Well, that's how you do it. Yeah, I guess it's going to be 2 because I copied it wrong. And that should be t squared minus 2t. Do you know how to simplify that? Can you integrate that by hand? Because it's t squared over 2t to the 1 half minus 2t over 2t to the 1 half. This is going to, the 2's will cancel. What's t to the first over t to the 1 half? T to the 1 half. Now this is 4 halves minus 1 half is 3 halves. So t to the 3 halves. Then it's just a power rule. Most likely, if they give you something like this, it'll be harder. And I'll be able to see it. It'll be bigger. But that's what you do. How about one of the other ones? Remember, I'm going to pick this up today. Your assignment is supposed to be done for today. Oh, collect it or mark it off, I don't care. What about, was 35 okay? 34 was the odd one because it was a horizontal slice. No, I said I wanted this done for today. You guys weren't working on it yesterday. You only had 5 problems. I agree. I'm going to come around with my little marking thing and then I'll do it. Okay? Let me stop this though. Honestly, I don't want you to tear it out either.